2013 collisions, question 5b. A ball is dropped on a table. It rises 1/4 of the previous fall. Find the coefficient of restitution between the ball and the table. So we're looking for E. So let's have a look here. Let's say the ball falls down to here and it goes back up. So this is H, this is 1/4 of H. What happens at the top here? It's gonna stop before falling back down again. And here my initial velocity is 0. So we have our going down, it's going to fall with an acceleration of g, and it's going to rise with an acceleration of minus g. So let's start with the fall and we get the speed. So v squared is equal to u squared plus 2as. So we're going to get v squared is equal to 0 plus 2gh. So my velocity at impact is the square root of 2gh. So the new speed on the way back up, this one here on the way back up, is going to be e times the square root of 2gh. Now it's slowing it down. So that's going to be my new speed on the way up. At this point at the top, the velocity is 0. So if I apply the same formula, 0 is equal to u squared. And we're going to have minus 2gh, and h is 1/4 of the original height, h over 4. So if I square the left hand one, e squared by 2gh, and I can bring the other one across, equals 2gh over 4. So 4e squared, the 2gh will give me a 1 over here. 4e squared is equal to 1. E squared is 1/4. So E would have to be 1/2. Part 2, sheets of paper are placed on the table. The coefficient of restitution decreases by a factor proportional to the thickness of the paper. When the thickness of the paper is 2.5 centimeters, it rises to only 1/9 of the fall. Find E, the coefficient of restitution between the ball and the paper. Okay, we have the same thing going on here. My height, and then it goes back up. I know this is not the scale, but it goes back 1/9 of the original height. So it's the same thing again. Well, let's call this E. Well, let's call this E1 this time. We had an E up here. We could call this one E1. Actually, maybe let's call that one E1 and this one E2. We have a third one coming up as well in part 3. So E2. So the speed of the ball, it's going to go back up and stop here where my velocity is 0. So v squared equals u squared plus 2as. 0 is equal to e2 times, well, it'll be the same as this one here, the square root of 2gh to be squared, and that's going to be minus 2g by my distance s, which is h over 9. So we're going to get, sorry, that's e2. I should have had the 2 down here, not up there. It's going to become e2 squared. So we're going to have e2 squared by 2gh is equal to 2gh over 9. So again, the same thing is going to happen. E squared is going to be 1 over 9. So e2 squared is going to be 1 over 9. So that would make e2 1/3. 1 over 3. Part 3, what thickness of paper is required in order that the rebound is 1/16 the height of the fall? Okay, same thing again. It's falling and it's going back up and it's stopping, and it's going to be 1/16 of the original height. So we can get E first, and then we're looking at the relationship between E1, E2 and E3. We'll call this one E3, based on the previous thickness of paper being 2.5 centimeters, which we haven't used yet. We're going to need now. So let's get E3. So it's the same maths again that you can see. V squared is equal to u squared plus 2as. 0 is equal to E3 by the speed, which is the square root of 2gh to be squared, minus 2g, and the height is h over 16. So E3 squared by 2gh is equal to 2gh over 16. divide across by 2GH, we're going to get E3 squared is equal to 1 over 16. So E3 will be 1 over 4. Now we need to look at the relationship between E1, E2, and E3 with no paper, the paper of 2.5 centimeters, and that's what they're looking for in this, what thickness of paper is in this part here. So we're told that if the sheets of paper placed on the table, the coefficient of restitution decreases by a factor proportional to the thickness of the paper. Well, we had a 2.5 and a factor, we'll call it K. So it started off as E1 and then it became E2 times 2.5K, a factor proportional to the thickness of the paper. So K is the only unknown between these two. So what we got a half, didn't we? A half for E1, a half, a third, and a quarter. Okay, so a half is equal to a third by, well, 2.5 is 5 over 2. It might be easier to write it as 5 over 2. Okay, so we're going to get 5K over 6 is equal to 1 over 2. So 10K is equal to 6. So K is equal to 6 over 10. And now the relationship between E and E1 and E3 is the same. We have K now. So let's have a look at what the thickness of the paper is. This guy is now the unknown. So E1 is equal to E3 by the thickness of the paper, we'll call it X, by K, which is 6 over 10. So it's just reversing the unknowns from that one. We got that one the last time. So 1 over 2 is equal to E3, which was 1 over 4 by 6 over 10 by X. So that we got 40 on the bottom here, multiplied by the left is going to be 40 over 2 is equal to 6x. So 20 is equal to 6x. So x is equal to 20 over 6 or 10 over 3. And do they ask us for, they don't ask us for rounding off, but this is in centimeters.